Hi everyone, in this video I want to talk about one-way ANCOVA. So I have this topic, the effect of different fertilization techniques on crop yield, controlling for soil quality. So if you look at my SPSS file here, so you will see that I've got my data set. So this is my dependent variable here, which is the crop yield, which I have measured and coded. And then you can see the soil quality here, which is the covariates. Okay, and then you can see the three fertilization techniques that I have here. So this one is the organic, you can see synthetic, and then you can see mixed, so which means the combination of both organic and synthesis. So I encourage you to sit relaxed and watch the tutorial to the end, so you'll be able to learn the procedures for conducting a one-way ANCOVA test, and then learn how you can interpret the results and write out the results in your own study. So the aim of this study is to determine if there is a significant effect on crop yield due to different fertilization technique after controlling for soil quality. So I have the following variables, just like I've explained before now. The independent variable here, the fertilization technique with three levels, the organic, synthetic, and mixed, just like I have explained here before now. And then the dependent variable is the crop yield. So here I measured it in kilogram per hectare, or you can measure in any other, use any other parameter to measure the crop yield. And so the covariate or confounding variable here is the soil quality measured by a soil quality index or specific soil properties such as nutrient content. So you can use any other threshold or parameters to check. The one-way ANCOVA analysis will give me the opportunity to control for the variability in soil quality and focus on the effect of the different fertilization techniques on crop yield. So that brings me to the research question that I've asked, or the study asked. And so it reads, after controlling for soil quality, do different fertilization techniques such as organic, synthetic, and mixed significantly impact crop yield? This can be a typical research question you may want to pose. Then for the hypothesis here, this is an alternative hypothesis that I've posed. So and it reads, there is a significant difference in crop yield among the different fertilization techniques after controlling for soil quality. So one thing about the ANCOVA there means that there is a presence of a covariate. So you want to control the effect of one variable or another variable in order to learn the actual effect of the independent variable on the dependent variable. So that is why we need to do an ANCOVA test. Supposing we do not have the presence of soil quality, then we might not need to do an ANCOVA. So there must be the presence of a covariate, a variable you name as a covariate. Before we can go on to run the one-way ANCOVA test, we need to check some assumptions. Now, the first assumption we want to check is the dependent variable normality check for the crop yield. That is, we want to be sure whether it is normally distributed. So to do that, I will head over to the SPSS. I will go to Analyze, Explore. Then I will put the crop yield, which is my dependent variable, into the dependent variable box. And then I will click the histogram and normality plots with test. Then under statistics, I do not need to do anything, but I can also tick here for outlier, so probably to check if I have any potential outlier. But in most cases, even if you do not check the outlier, the normal test, the test of plot, will still generate the outlier boxes for you to check whether there are potential outliers. So I will click OK. And so you can see this is the analysis, the normality, the test of normality, and our particular interest in this test is the Shapiro-Wilk test. Here we need to be sure that this sig value, which is the significant value, is above 0.05 significant alpha level. So if this sig value is less than 0.05, it means that our data are not normally distributed. Another one is the Kolmogorov-Smirnov test, which also is not statistically significant, so indicating that this data, the dependent variable, are considered to be normally distributed. So another way to also check is for the outlier is to also look at the rectangular box. So you can see we do not have any potential outlier. So assuming we have any outlier, then you can see that the outliers will show either here or at the down part of the rectangular box. So from the box plot, you can see that we do not have any evidence of potential outlier in the data set. So the first assumption has been checked and met. Then we will proceed to the second one, which is the homogeneity of variance test. But before the homogeneity of variance test, let us check the linearity, because one more assumption you need to meet is that the relationship between the covariate and the dependent variable should be linear. Okay, now to do this, we head over to the SPSS. So we go to Analyze, Regression, Linear. So we put the crop yield, which is our dependent variable, into the dependent variable box. And then we will fix the soil quality, which is our covariate, into the independent variable box. Then we go to the plot. In the plot, we will put the Z predictor into the X box. And then we put the residual into the Y box. And then we select OK. And then we click OK to check whether there is any significant relationship between the two variables, the covariate and the dependent variable. So you can see this is the summary box, and this is the ANCOVA, typical ANCOVA test, and that the F test is statistically significant in the regression analysis ANCOVA box. But this is where we have our interest there, which is on the coefficient. We need to be sure that the relationship between the soil quality, which is our covariate in the analysis, and the crop yield is statistically significant. So this is a typical example of linear regression analysis. So you can see the standardized coefficient beta is 0.267, which is 0.27 if you approximate, and is less than 0.05 significant alpha level. Okay, so which means that one of the second assumption has been met, that is, the linearity has been met. Then, but again, let us also go down to the scatter plot if we want to check. So one way to use the scatter plot to also check is to double click here and then insert the linear line. So you can see that the line is actually linear. You can see from this part, the part here to this part is linear, and you can see that the relationships fall within -0.3 and within the +3. So showing that, see, within -0.3 and +3. the scatter plot fell in within the threshold, showing evidence of linearity. So which means that the second assumption here has been met. The next one is homogeneity of variances. So this is the one that we will have to check while we conduct the one-way ANCOVA test. So the next one is the homogeneity of variances test, which we will check while we conduct the one-way ANCOVA test. So after satisfying the assumptions, one can now proceed to do the one-way ANCOVA test. So to perform the analysis, I will go to Analyze General Linear Model Univariates. Now you can see that the variables have now loaded. Okay, and remember that for you to if you are a doctoral student or master's degree student, you need to report meeting this evidence of meeting these assumptions in your study. So so these particular summary reports, the coefficient and then the scatter plot are important for you to report. To perform the one-way ANCOVA test, we will put the crop yield, which is our dependent variable, into the dependent variable box, and the fertilizer application or fertilization technique into the fixed factors, and then we will put the soil quality into the covariates. So this is what makes it one-way ANCOVA test. Under the model, we will leave the model at default, full factorial, and sum of squares type 3. So we do not need to do anything here. We click continue. Under the contrast, we do not need to do anything here, so continue. Under the plots, we will simply take the independent variable into the horizontal box, the horizontal axis, and then click add to drop it into the plot, and we click OK. Into the EM means, estimated marginal means, we need to select the both and put into the display means for all of them, and then click compare means. Here, under the confidence interval adjustment, we will select Bonferroni, and then we click continue. Under the option box, we want to select the estimate of effect size and the homogeneity test. Remember, this is the next assumption that we need to meet here. We'll click continue, and then we click OK to produce the results that we want to see. Looking at the results, you can see that this is the univariate analysis of variance, which is one-way ANCOVA test. So here we have the box between subject factors. So we have three different factors here. That is the organic, synthetic, and mixed, and here is the number of cases. Okay, so you can see that the organic, under the organic, we have 15 cases, 15 test cases, and then synthetic 46 cases, and then mixed 29 cases. All right, and so the Levene's test of equality of error variances, you can see that here this is one of the assumptions that I talked about, homogeneity of variances. So this is the test here, which is the Levene's test of equality of error variances. So here our interest is to be sure that we do not have a statistically significant result here. So if the test is not statistically significant, it means that we have, as it is currently, it means that we have not violated the assumption of homogeneity of equal variances. Okay, then the next one is tests of between subject effects. So here our interest is on the application, the fertilizer application. So you can see that this is statistically significant, which indicates that we do not accept, or we fail to accept, the null hypothesis. So we can actually agree with the hypothesis that we posed, that there is a significant difference in crop yield among the different fertilization techniques after controlling for the soil quality. And then here we can see that the soil quality, the controlling for the soil quality, is statistically significant. So you can see that the statistically significant result supports the analysis, the finding that we have here, that there's a statistically significant difference in crop yield among the different fertilizer technique, because you can see that the covariate here, after controlling for the soil quality, is also statistically significant, and this is the partial eta squared value, which is 4.7%. So you can see that in the fertilizer application that we have 27.9% of variance explained in the analysis, and this is the R square and then the adjusted R square values. If you want to report the both values in your work, the estimates, this is an important table that you also want to look at. Now, if you look at this table, this is where you can see the means. So you have an idea how each of the factors, that is the fertilization application, is doing. So here you can see that the mean for the mixed method, the mixed application, is 34.426, indicating that it has the higher mean among the other groups. The second one is the organic, followed by the synthetic. Okay. So one way to show this, if you want to, on a face value, is to use the graph. So to do that, you go to graph builder, select OK, and then you will take the crop yield, okay, which is on our y-axis, that's our dependent variable. Then you will select the fertilizer into the independent variable box axis, that is the x, and so you click OK. So you can see, if you look at the simple bar mean of crop yield by fertilizer application, so you can see that the mixed has the higher mean, so which means this has more effect on crop yield. That is the mixture of organic and synthetic, which is the mixed fertilization application, has higher yield, higher effect on the crop yield. So that is next to organic and next to synthetic. So let me take you back there a little more. So you can see this is 34.426 followed by 25.922 and 23.801. Okay, and so that is showing here, and then lastly here. Okay, so the next table we want to look at is the pairwise comparison. So in the pairwise comparison, you will see that anyone that is not statistically significant, you will see that the sig value will be on 1.00, and then you can also confirm that using the bootstrap confidence interval, which will indicate that 0 falls between the null. You can see this is negative 3.532 and positive 7.774, so indicating that 0 falls between the null. All right, so that is another way to confirm whether your result is achieving a statistically significant result or not. So, but you can see that the comparison between organic and mixed method is statistically significant, but negative. So when compared to mixed, is less. Okay, so you can see that when compared to mixed, that shows you that it should be less. Look at that. And then under the synthesis, when compared to organic, it's not statistically significant. So we do not have any evidence of significant increase or decrease. We do not have any statistical evidence on this. And you can also look at the bootstrap confidence interval, which will also give you an idea of how this is faring. So you can see that 0 falls between the null. Now the next one is that when you compare the synthetic and mixed application, you will see that this is statistically significant, and that is really a reduction in that. You can see this is statistically significant, and you can see that this is the 0 did not fall between the null here. You can see this is negative and this is also negative, so confirming the statistically significant result that we've got here. Then on the mixed method, mixed application, you can see that that is the combination of the organic and synthetic. You can see that when compared to organic, we have a statistically significant result here, but positive in this time. Okay, so that will also give you an idea. If you look at this, you can always look at this graph here. That will always give you an idea. And then under the when we compare the mixed and synthetic, so that will tell us that the mixed has a higher value, a higher contributes higher than organic and synthetic. So you can see the sig value here, and then the mean difference is 10.625. okay, that is 10.63. And then you can see that 0 did not fall between the null at both cases. All right, so one way to look at, so this is the univariate test for the dependent variable. So you can also report this as your model if you want, but this you can actually overlook this pairwise comparison among the estimated marginal means. Now you can also look at the profile plots. Okay, this plot can also help you to understand that so you can see the organic, so that can also help you to look here. Okay, so when you compare the organic to synthetic and mixed approach, you can see that there is really evidence of an increase in the yield of crop yield here when compared to the synthetic and when compared to the organic. So you can see that here. This is the mixed. You can see the point. This is the synthetic. You can also see the point, and this is the organic. Okay. So let me pause the video and then interpret the results and then paste it for you so you'll be able to read it out. So you can see how I have extracted some important information from the entire analysis. And remember that if you are a doctoral student, you need to report the normality tests. And one way to also, if you want to put the normality line in this graph, in this histogram, you can double click here and then go to elements and show curve. Okay, so that is one way to report this. So you might want to put this into your work if you need this. And then this is the normal QQ plots, and you can see that this is also showing evidence of potential approximately normally distributed data, because it might be difficult to get data that are normally distributed, accurately normally distributed. So this is evidence of that the data are considered to be normally distributed. Okay, and this is also evidence that you do not have any potential outlier in the data set. So you need to report this for checking the linearity between the dependent variable and the covariate. So you also need to report this and then use the scatter plot to also show that before you can now begin to report the results for the one-way ANCOVA test. So let me take you to the main result that I've got. So you can see the first one I reported here is, supposing I write this to be results in my journal article or in my thesis. So I would like to start with this as part of my results. The other ones can be reported under methodology or a preliminary analysis. Okay, preliminary data checks. So you can see here, I tried to capture the table using this particular sentence here. You can be more innovative in reporting your own, but I've just given you a little idea of one way you can report that. So I said the analysis showed that the mean differences for the mixed application, that is this, is higher than those of organic and synthetic. So you can see that the mixed, this is the mixed, the organic, this is that of the organic, and this is the mean for synthetic. So that can also guide you. So you might want to pull this table if you want. You can also use this to support this analysis here. You can fix your table here and then make a sentence to indicate that this is just the visual representation of what has been reported in the table. Then the next is the pairwise comparison test, so which I have also talked about before now. So this is how I reported that. So you can pause the video and then read this. So this is just elementary way of reporting it, so you can make more meaning out of the results and then find a way to make it more innovative. And this is the estimated marginal means of crop yield. Okay, so this is the plot, profile plot, that you may also want to display to support your interpretation of the results. So I hope you find this video helpful. If you have questions and comments, I'd like to read them in the comment section below, and then I look forward to addressing them in subsequent videos. Thank you so much for watching. Please share and like the video. Thank you.